Hello, today we're going to talk about direct variation. So direct variation is a function in this form where this k is the constant of variation. Yep. And k is not equal to 0. So basically it's slope. Basically, it's found the same way and you basically do everything the same, but there's a fancy name, so we need to do a new lesson over it. So the direct variation finds the rate of change. The rate of change is also another name for slope. So this is just a video over slope, basically with a couple problems at the end that change. All right, just make sure you understand what the direct variation is. This function right here, even though it has a y instead of the fx. What is the constant of variation for these? Or what's a direct variation? Well, this one, your k equals 7. Here, your k equals 1/2. Over here, your k equals 18. So it's where your slope always is. Hence, it being slope or the rate of change, which are all the same thing. All right, so for our first example, right here. So we have distance over hours. How we would say this is our distance varies directly with hours. So what this means is distance varies directly with hours is you'll have distance over hours or y over x. Looks kind of like slope, doesn't it? So I have 2 points right here. So now I need to find what the y over the x would be. You do it whichever way you sort of want. Go up and over. So how many did it take me to get from this spot right here up to there? So I was at 25 and I got to 50, so 25. I was at 5 and I got to 10, so 5. So my distance here is 25, or it's my y, over my x, or my hours, so it's 5. If you want to use the slope formula, you do 10, 50, and 5, 25, 1, 2, x, y, x, y, 1, 1, 2, 2, 25 minus 50, over 5 minus 10, which gives you 25 over 5, both negative, which is just 5. There you go. So the distance varies directly with hours. Distance will be your y, hours will be your x. All right, here's our second example. We're looking for that m there. So if I say how many does it take to get from here to here? 6. How many does it take from here to here? 6. All right. So how many does it take to get from here to here and here to here? Well, this whole thing is 24. So if it's constant, if this goes up by 6, how can I split 24 in half? Yes. So I could say 12 and 12 to get there. So this has to be 36. The other way you can do it is come up with a formula and whatnot, but if I do that, that's a lot easier. Now we're going to find the constant of variation, or the k right here, also known as slope. You find it the same way too. So I have 2 points. Use the slope formula. One, 2, x, y, x, y. Since these are my 2's, I put a 2 down there. Plug everything in. 36 minus 12 over 9 minus 3 gives me 24 over 6, which is 4. That is my constant of variation, or my slope, whatever you want to call it. Here, you can use the points 0, 0, and point 1, 2. to do it. So I call that 1, I call that 2, x, y, 1, 1, 2, 2. Y, oops. So I use my slope formula. So it's 2 minus 0 over 1 minus 0, so it's 2 over 1 or 2. The other way to do it is do rise over run. So I'll rise until I get to the point, and I'll go over to make my right triangle. So that went up 2 over 1. It's always y over x. So you can say, call this cookies, call this hours. So this would be cookies varies directly with hours. So 2 over 1 is 2. Either way is fine. All right, last one here, last two. So of direct variation, or find the constant of variation. All right. So fat calories varies directly with fat grams. So that means I'll have fat calories over fat grams, or grams of fat, whatever you want to call it. So if I have 27 fat calories for every 3 fat grams, my constant of variation is 9. So John's paycheck varies directly with his hours of work. So paycheck over hours. John works 5 hours, makes $60. So he makes $12 per hour. All right, but what if John works 8 hours? He'll make $96. And there you go. That's how you do it. This has been direct variation. Hope it helped.